As you write more shell scripts, you will often find that you need to repeat an action a specific number of times. While you could write duplicate code, it isn't maintainable and doesn't work if the number of times the code needs to be executed can vary. This is where loops can be beneficial. Loops allow you to write code once and have it executed multiple times. There are two types of loops: definite loops and indefinite loops. Definite loops are loops where you know the number of times it will be executed before the loop ever starts. Indefinite loops are loops where you do not know the number of times it will be executed, since it depends on things like user input. Do not confuse an indefinite loop with an infinite loop. An infinite loop is a loop that never ends, whether by design or accident. Examples of both types of loops can be found in the loopexamples.sh script. Let's look at definite loops first. In Bash scripts, definite loops are commonly implemented using a for loop. Let's look at the first for loop. The part that determines how many loops are executed comes in between the keyword for and the semicolon. In this case, the loop will run 5 times as it uses the 5 hard-coded values 1, 2, 3, 4, 5 as values for the variable I. I is frequently used in loops for the current index of the loop. This is called a programming idiom. The keywords do and done indicate the body of the loop. The code in the body is executed every time the loop is run. In this case, the body simply echoes the value of the $I variable. If we look at the second loop, we see that we can generate the same sequence instead of having to hard code it. This produces the numbers 1, 2, 3, 4, and 5. You can generate more complex sequences using this syntax, but this one is sufficient for right now. The third loop shows another way to represent a for loop. In the first two loops, the value of the variable $I was specified by a sequence of values. In this loop, however, we are using arithmetic and numerical comparisons to determine the next value of $I and the number of times the loop will execute. Since we are doing arithmetic, we have to wrap the contents of the loop definition in double parentheses. The body of the loop does the same thing as previous loops. The for statement itself is just different. The last loop generates a sequence using a different approach. In this case, it uses an asterisk wildcard to match all the .sh scripts in the current directory. I frequently use this approach in my scripts to process every file in a directory. Here, it stores the name of the first file in the file variable and then uses it in the body of the loop. Once the body has completed, the name of the next file is stored in the file variable, and so on until every script file has been processed. The nice thing is that you can use all the utilities and commands of the shell to generate this list of files. In fact, I frequently use sed to build file names corresponding to directories, which I then process in a for loop. For each of these loop examples, we knew how many loops would be executed before the for loop started executing. However, we aren't always this lucky. Sometimes we don't know when a loop will end until some criteria is met. These indefinite loops are often implemented using a while loop. To simplify the code for this loop, I'm using a simple counter variable. It isn't a good example of an indefinite loop, but it does make the loop itself easy to understand. In this case, the loop executes as long as the counter is larger than 0. Once that criteria is false, the loop finishes. The value of the counter is changed inside the loop. If we never change the value, the test would never evaluate to false, and the loop would continue to execute forever. This is commonly referred to as an infinite loop. It is possible that this while loop will never execute. If we change the value of counter to 0, the test would never evaluate to true, and the entire loop body would be skipped before it is ever executed. Let's run this script and see what its output is. Since there is a lot of output, I'm going to pipe it to less to make it easier to see. Notice that the output of the first 3 loops is the same. The body of each loop was the same. We just changed how we defined the number of loops and the value of I. The 4th loop that processed each of the script files printed out the file name and the last line of the file. Lastly, the while loop decremented the counter until it reached to 0, and blast off was printed. While I have tried to distinguish between definite and indefinite loops in this video, the line between their implementations is a blurry one. As we saw with the while loop, we can implement what is basically a definite loop using something primarily used with indefinite loops. The distinction between the two should be thought of as something that can help you determine which one to use, and not a rule that must be followed.